Okay, class, we're going to solve a rational inequality. Here is our rational function, f of x, which is equal to x plus 3 divided by x minus 2. And we're trying to find all the x's in the domain, that when you plug them into the function, you will get a range value or a y value that is equal to 0 or can be less than 0. Okay, so what I'm going to do first is I'm going to figure out where the function is equal to 0. Okay, so remember that when we solve an inequality, we always want to solve the equality. Okay, did I say that correctly? When I want to solve an inequality, okay, I have to first solve the equality. So, where is this function equal to 0? Well, it's equal to 0 where the numerator is 0, right? And so now that's going to be at negative 3. Okay? And so x equals negative 3 will make the function equal to 0, and that's partly what you wanted. So I know that in the end, negative 3 will be part of my final solution. Now, when you're dealing with rational functions, they could possibly change signs around their vertical asymptotes. So the next thing we need to do is figure out where f of x becomes undefined. And it's going to become undefined where its denominator is 0. Okay, so that's going to be at 2. All right, so now the next step is to cut our domain using these values that we got from step number 1. Okay, and that's going to create what we call the subintervals. Okay, so the domain gets cut up into subintervals using the values from step number 1. Okay, there's our x-axis. And now we're going to determine the sign of f of x on each of those subintervals. Okay, but hold on, let's get back to what we said a moment ago. When x is negative 3, the function equals to 0. When x is 2, the function is undefined. Okay, so I know that this number in the end cannot be included in the final solution. I'm putting the word no here to remind me. Okay, no, because it makes the function undefined. And if you're undefined, you cannot be equal to 0, nor can you be negative. Okay, to be less than 0 means to be a negative number. And in order to be negative, you have to be real. Okay, defined. All right, so now step number 3 is we're going to determine the sign. Determine the sign, S-I-G-N, of f of x on each subinterval. Okay, and if you know the graph of f of x, okay, this rational functions graph, you could certainly make a sketch of it and then determine whether or not you've got pluses or minuses, or we can use test values. Okay, so why don't we do that? On the interval where the x's are less than negative 3, I'll pick negative 4. So if I pick negative 4, it's going to go into the numerator. So negative 4 plus 3 divided by negative 4 minus 2. And that's going to give us a negative number divided by a negative, which will determine, which will give us a plus sign. Okay, so that one negative number makes a positive y value, and the function is going to have the same sign on that entire subinterval. Okay. Now, if I pick a a test value in this subinterval, such as 0, and I plug in 0 into the function, I get 0 plus 3 would be a positive 3. Okay. 0 minus 2 is a negative 2. And so that will produce a negative y value. and therefore my function is taking on negative y values, okay? And that means that if you were to actually make the graph of f of x, the graph would lie entirely underneath the x-axis, right? And then lastly, in this last subinterval, where the x's are greater than 2, let's pick a number like 3. So 3 plus 3 would give me a 6 on top, that's positive. 3 minus 2 is 1. And so I've got positive divided by positive, which is positive. Okay? And so the last thing that we need to do is write the final answer using interval notation. So let's go back to what we originally set out to do. What are the x's in the domain that will make these y values, these function values, become equal to 0 or be less than 0? So that means that on my sign chart, I'm looking for where the y values are equal to 0, which is right here, or where they're negative. That means that I'm looking for the minus signs. Okay, so my final solution is including negative 3, so I'm going to put a square bracket on it, then all these numbers that are less than 2. But 2 is not included because that's where we actually have a vertical asymptote. Okay, so there is your solution to that rational inequality.